My name is Andrei Yurchenko, and I wanted to show you something really interesting, which is a research coming out of a Japanese artificial intelligence company, Sakana AI, which concerns about how do we make the language models learn. The current state of the art is that you just insert the information that you want into the context window, and then you add whatever operations you want to perform on this data, and that's how it works. This new approach, instead of putting the information directly into context window and forcing to tokenize it and process it, it feeds this information to a hypernetwork, which outputs the low rank adapter, which is then applied to the language model that is used to process the context. So that means that you free up the context space, and then you free up these processing cycles because you don't have to process that data anymore. So I thought that it was really exciting. And also the authors of the paper include the code to test this approach. But unfortunately, I was not able to run it on my smaller GPU. But luckily, I have DGX Spark. And I made this Dockerized setup to run the code from the paper. I mean, pretty much in one shot in plug and play fashion. And I wanted to show you how it works. So this is the GUI, the user interface of the application that they built. And the first step that we need to do is we need to select the checkpoint. So that's the checkpoint for the train hypernetwork that will convert our knowledge, our information, into the LoRa adapter. So I already pre-selected this one. This is the Gemma checkpoint 80,000 because it takes a couple of minutes to load it. So I didn't want to just sit here twiddling the thumbs. So you see it's loaded the checkpoint. The base model is pretty small. So you see that it's only 2 billion parameters model, which is kind of interesting. And this is the blurb of text that is used to inject the information into the model. And before I start asking the questions, because here it is the conversation where I can ask the questions to the language model, I wanted to show you that it's really trivial to change, and I will change the number, so the company value, and now I can ask a question, and also I change the year, 25. So I can ask a question: how much is Sakana AI worth? And you see that instantly the knowledge from this text was applied to this. Now we can ask about the year. When? 2024. Well, we see that's wrong. So probably it maybe got confused with the other years because there's a lot of 2024 in that article. So that's something, again, that maybe that's early result as well. But let's make another experiment, and let's just use some other domain, not something that they guaranteed they have not trained on. So let's talk about VPP. So those of you who know me, I have spent, and I'm still spending time with working on a project called VPP, which is Vector Packet Processor. So we can ask, what is VPP? And it's thinking. Let's see what it tells us about it. So the answer is almost correct, as you can see, but it's, well, it's in the same area, but it's not correct. So we need to fix that. So I'll put VPP is Vector Packet Processor, an open source project that is part of Linux Foundation. So it's not a good wording, but let's see. So we can say, can you double check and see if that works? So you see that that information immediately took hold, but it's not entirely fully correct, right? So you see that it's the packet processor took the effect, but vector packet processor didn't quite go here. So let's increase the context scaling, which is the extent to which this LoRa adapter influences, and ask, are you sure? So it's still pretty short. So I think we'll probably need to reset the chat, because this this context here probably is influencing the inference. So now we can see is VPP. So VPP is an open source project that is part of Linux Foundation, which is kind of correct. Can you abbreviate? So yeah, so you can see that the data has taken hold and it's working. So now we can ask, what is the project website? Okay, so VPP project website is not provided in the context. The website is at. So we can ask it to double check, and we see. All right, so still that's probably, again, we see the same thing in this case, that it's influencing the previous context is influencing the reply. So we reset and ask. And you see that indeed now the answer has taken place, and that is correct. So as you see, the really cool part of this is that it's fairly instant, and that information becomes part of the language model itself by low rank adapter. And you also see some example of how the previous context will affect the inference for the new information, even if there is the low rank adapter. So that's something to be wary of. And yeah, so again, as I said, if you have DGX Spark, then you can very easily recreate it on your own setup. If you don't, then you can click from here, you can click to the study itself. So they have a pretty good Python code which you can run if you have a bigger GPU. So I think that's it. Thank you very much. I hope you enjoyed it, and see you another time.